So, mark your own. Here we go. She does. Suppose this mass begins from rest. I'll underline the word from rest. Mass 1 is 2.2, mu is 0.44, gotcha. Angle of inclination is 53 degrees, that's one down there. Find the time that it would take this mass to slide 4.8 meters down the slope. So I'm going to make a little note. I guess they want me to find t. I know VI is 0. I know D is 4.8. I think I could find T if I can figure out A. How am I going to find A? This is a job for a free body diagram. What are the forces acting on this mass? Get the obvious one. mg. And that's going to be broken into perpendicular and parallel. And that angle there will be that angle there. Is this mass sinking into the ramp? Is it flying into the air? There has to be a matching perpendicular to the ramp force, normal force, which will be the same size as mg perpendicular, unless there are other external forces, which I don't see here. And which way is this mass sliding? It says down the slope, so I think it's sliding down the slope, which means friction is pointing up the slope. What if this were sliding up the slope? What would I change in my free body diagram here? Only one thing. Friction will be pointing down the slope. I get a slightly different equation. Who's winning? I think friction is losing, and that's going to equal MA, winner minus loser. This is going to be mg parallel minus mu times the normal force equals ma. I don't know the normal force. Oh, but look. Another force the same size as the normal force. This is going to be mg parallel minus mu mg perpendicular equals ma. At this stage, now you don't have to, but I notice there's an m in everything, and so I can cancel it out. You don't have to. You could put the m of 2.2 kilograms. So it looks like A is going to be g parallel, which is g sine theta, minus mu g cos theta. A is going to be 9.8 sine 53 minus point, I should have looked up what mu was, 0.44 times 9.8 cos 53, 9.8 sine 53 minus 0.44 times 9.8 cos 53. I get an acceleration of 5.2316. You know what? There's a 0 after the 6. That gives me 5 sig figs. That's probably a good place to round off. 5.2316. 5.2316 meters per second squared. But now, let's actually answer the question. D equals a half AT squared. What happened to the VIT? It starts from rest. D is going to be 0.5, 5.2316. Did I have a time? No, not. I need to get T by itself, Mr. Dewick. Sheesh. Let's do it this way. My brain was finding the wrong thing. It's going to be 2 times D over A square rooted. It's going to be 2 times, what was the distance? 4.8 divided by 5.2316 square rooted. If I do that, 2 times 4.8 divided by... Do I need to let any of these be negative? We're going down the hill. No, wait, I think we called that winners, so I'm okay there. Am I speeding up or slowing down? I'm speeding up, so I don't need to call this a negative acceleration for the kinematics portion. Am I made a mistake?
Shouldn't you put a bracket around the
Won't make a difference on my calculator. It'll only make a difference if there's a plus sign between them, but if everything on the top is being multiplied, my calculator will assume anything in front of it with a times sign is on the top. Square root. You get 1.35?
Yes.
If you got that, what was this question worth? Really should be worth, wow. 4 out of 4, I would probably do something like this. 1, 2, 3, 4, 5, 6, 7, 8. Sure, that works. If you get it right, 4 out of 4. Otherwise, I'd probably give you a half mark for each of these lines. For a lovely 4 marks. Number 2. Now, on your test, first of all, what am I asking you to find in question 2b? Missing mass. I'm going to ask you to find the missing mass either for a situation like this or for a situation where you have one mass hanging and one mass on a flat surface. It's very similar. Okay? I don't know which one. I did several different versions of the test on the weekend, and I know I flip-flopped between them as I made them. So find the missing mass. Oh, and I'll either tell you the acceleration or I'll tell you the tension. If I tell you the tension, you can use that to find the acceleration. If I tell you the acceleration, you can use that to find the, knock, knock, who's there? Tension. M1 is accelerating upwards, and I know M1, so I'm going to start out with a free body diagram on M1. I have M1G tension, and that lets me write an equation. I know tension is winning because it's accelerating upwards. Minus M1G equals M1A. If it was accelerating downwards, it would be M1G minus tension equals M1A. I do the swappy dance to get T by itself, but it's going to be fairly similar here. I'm going to get tension equals M1G plus M1A. Tension is going to be 5.9 times 9.8 plus 5.9 times 3.6. Can I do this in my head? Oh, maybe. 9.8, 12.8, 13.4. Yeah, no, this one's yucky. Clear. 5.9 times 9.8 plus 5.9 times 3.6. Do you get 79.1?
Yeah.
79.06, I'd take that. I'll write to 3 sig figs 79.1, but I'll store that on my calculator. If you got that right, 2 out of 2. Otherwise, I would give you 1 mark for that, half mark for that, and a half mark for the answer. Find M2. Now I need a free body diagram on M2. I think I'm going to have M2G tension. I think there it's going to be M2G minus tension equals M2A. How many M2s do I have, Caleb?
You have 1.
2. How many M2s would I prefer? 1. Get them to the same side. So I'll get this. M2G minus M2A equals tension. How many M2s do I have, Caleb?
2.
How many would I prefer?
1.
Be wonderful as a grade 9 mathematical operation that I could pull out of my back pocket, as it were.
M2 bracket G minus A. No greatest common.
So I'm going to get M2 equals tension divided by G minus A. It's going to be 79.06. Was it 06? Yeah. Divided by 9.8 minus 3.6. Divided by, definitely have to have a bracketer on the bottom because plus sign. $12.8? Yeah, 12.75. I'll go 12.8. Kilograms. 2 marks for that. Otherwise, I would give you, probably half mark for that. I would give you 1 whole mark if I saw that line, and a half mark for the answer. Then, I would turn the page. A student of mystery mass M places a bathroom scale on a skateboard. He rolls forward on, you know what? If you're on level ground, the scale reads the same. What's more interesting is B, more than M, less than M, or M. You know, I think I'm going to dulp. There's the skateboard. But I can't draw a student. I'll just treat it like a block. It's all you are to me, yes. Just blockheads. MG. Components. MG perpendicular. MG parallel. I got them mixed up and backwards, Mr. Dewick. Don't do that. MG, you said perpendicular, but you wrote parallel. That'd be silly. Wow, that suddenly moved on me. Normal force. Why is 3 the correct answer? Okay. So I would accept that. Now, if I want to go really algebraic, I would say something like this. Fn equals mg cos theta, comma, which is always less than mg. Now, why is it always less than mg? You may have noticed this. When you hit the cosine button, you always get a decimal less than 1. Or 1 exactly, but you only get that if you were flat. So if you did a good free body diagram and you feel you've given a clear explanation, I'll give you 2 out of 2. If you're not sure about your explanation, show me later on when I say come lawyer with me, and I'll say, yeah, I'll give you that or whatever. This is kind of a vague one, but definitely I think my approach would have been a good free body diagram. This would have been maybe a good time to use my, well, if theta is 0, if theta is 90, you're looking at both extreme values. I would certainly take that as well as a good answer. An even better answer, see, you're at a bit of a disadvantage because you haven't seen the trig graph yet. I know that the trig graph between 0 degrees and 90 degrees starts at 1 and gets smaller for the graph of y equals cos theta. So not only do I know that it's less than mg, I know that the closer you get to 90 degrees, since cosine gets close to 0, mg times cosine will get close to 0. There's a graphic proof of why the normal force will be 0 when you get to 90. There's all sorts of options. You can go really, really deep. But you haven't seen those graphs yet. Number 4. So there's absolutely, I'm pretty sure, wow, that was very convincing, on several versions of my test, but I don't think on all versions of my test, I put an Atwood machine with a ramp. Don't think I put it on all of them, but it's definitely on at least half of them. I think here I didn't have friction. I think on your test I included friction from the get-go. All right, this is a job for a free body diagram. M1G tension, M2G, M2G perpendicular, M2G parallel, that's theta, normal force number 2 to go with mass number 2, tension. It says find the acceleration of the system. So who's winning? I'm not sure. I can quickly compare though. I can compare M1G, which is 11 times 9.8, and I can compare M2G parallel, which is going to be 7.8 times 9.8 times cosine of, what's theta, Mr. Dewick, 36? Actually, I didn't even need to do that. If there's no friction, and this mass is lighter, Braden, there's no way that M2 could be a winner. Friction would have to be involved for M2 to be a winner. M2G, sorry I said M2, for M2G parallel to be a winner. And sure enough. So, what's my equation going to look like? Winner minus loser plus winner minus M2G parallel equals M all times A. I don't know yet. I haven't got there yet.
No, if you had.
Oh, if there was friction, you would have to then decide which way mass 2 was moving. Since mass 2 is accelerating up, friction will be pointing down the ramp. Okay? It's entirely possible, though, if you ran the numbers, that the combination of M2G parallel and friction could be winning. Like, that's why you said I just minus it. Actually, they might be the winners. This mass could be slowing down going uphill. So I can't quite answer your question the way you want me to. You'd have to figure out which way is it sliding. Friction points the opposite way, and usually it'll end up being a loser, but I can conceive of a situation where, friction is so big, actually it's slowing everything down. This is going to come to a stop. This would be the classic how the Grinch stole Christmas at the top of the mountain. There's your sled, and here is the Grinch desperately trying to bring it to a stop. That'd be a good one to analyze as a word problem. Note to self, maybe on my test next year. All the who's down in Whoville? Nothing? Okay. A is going to be M1G, no component there. I don't know why that G moved down like that, Mr. Dewick. M1G, no component there, because that's nice and vertical in line with everything. Minus M2G sine theta all over M1 plus M2. A is going to be M1G 11 times 9.8 minus 7.8 times 9.8 cos 36, all divided by 18.8. I bravely added them together in my head. (11 times 9.8 minus 7.8 times 9.8 cos 36 divided by 18.8. Double check. Mg minus Mg parallel. Parallel, Mr. Dewick. Why am I going cos all of a sudden here? That was silly. It's sine, Mr. Dewick. See the sine, Mr. Dewick. You even wrote sine up there. Let's fix that. Sine. Wow, that was strange. Do you get 3.34? And this one does have a built-in error check. It wouldn't be bigger than 9.8. A equals 3.34 meters per second squared. If you got that 2 out of 2, otherwise I would probably go something like half mark for that, half mark for that, half mark for the numbers, and a half mark for the answer. Find the tension in the rope. You could use mass 2. I'm going to use mass 1. M1G minus tension equals M1A. Time for the swappy dance. Tension is going to be M1G minus M1A. It's going to be, what was M1? 11 times 9.8 minus 11 times 3.34. Of course, Dmitry, you know I'm going to use my answer button there instead of writing the 3.34. 11 times 9.8 minus 11 times answer button. Do you all get a tension of 71 even? No? Yes? 71.0? If you use the 3.34 and not your answer button, you'll probably be within 2 sig figs, but your third sig fig might be a bit wonky. Now, C asks, what would be the minimum coefficient of friction to hold this thing stationary? If I wanted this not to move, which way would friction have to be pointing? Down the ramp. So I'll just draw this in now. After the fact, I would have friction that way. And in fact, I think what I would end up with is a tug of war between M1G. The tensions would cancel, and I would have minus m2g parallel minus friction force number 2, and that would equal 0. Or if you're really, really clever, Kevin, what you could do is that, plus them both over to the 0 side. Really, everything down the ramp straight down on the left is going to equal everything down the ramp on the right, because that's how this would remain in equilibrium, how this would remain stationary. So m1g is going to equal m2g sine theta plus mu m2g cos theta. And I guess now I need to get the mu by itself. Mu is going to be m1g minus m2g sine theta, and I think all divided by m2g cos theta. Is that right, folks? I think. Masses don't cancel here, sadly. M1 was 11 times 9.8 minus M2 was 7 point something. 7.8 times 9.8 cos 36 sine 30. I did it again. Wow. 36, close off the sine, close off the top, divided by bracket M2, which was 7.8 times 9.8 cos 36. And this is where I said I've made up bad numbers. Did you get an answer like a tiny bit above 1? 1.02 technically. I'd take 1.01. It depends what you use for some of these. Oh, no, these aren't rounded off values. Should get 1.016. It's 1.02. Units from you? None. Okay. There is going to be a question somewhere on your test where I ask you to find a coefficient of friction. Almost certainly on an angle, but not necessarily. If you got that right, 2 out of 2. Otherwise, I would probably go 1 mark, half mark, half mark, half mark. Number 5 wants me to find the coefficient of friction between the skis and the slope surface. Okay, this looks like it's a job for a free body diagram. I'm going to have mg. I'll break it up into mg perpendicular and mg parallel. Looks like I'm going to have a normal force. Friction, it does say there's friction, and we're sliding down, so friction's going to be like that. It says the speed is from rest, and we reach 20 meters per second, so I know we're speeding up, which means winner must be down the slope. Who's winning? mg parallel minus friction equals ma. mg sine theta minus mu mg cos theta equals ma. I want to get the mu by itself. I'm going to do the swappy dance. I'll plus that there, minus that there. That's going to give me mg sine theta minus ma. That equals mu mg cos theta. Although I guess to get the mu by itself, I'll just divide by mg cos theta. I guess, I wasn't paying attention. I really could have canceled out the m's. In fact, I could have canceled them out on the previous line. There is an m in everything. I went on my rant about how that explains why a grown-up skier and a little kid skier can ski side by side. Yeah. Even with friction taken into account. The only slight difference would be bigger surface area for the adult does mean more air resistance, but at slow speeds, it'd be negligible. It'd only be if you were trying to compete downhill speeds, really skiing fast, that it would make a big difference. I got a problem here. I get mu equals g sine theta minus a all over g cos theta. I don't know. So, it did say from rest. it gave me a V final of 20. And, it gave me a time of, what was it, 8? So I can go T equals VF, T equals, Mr. Dewick? A equals VF minus VI all over T. It's 20 minus 0 all over 8. 20 over 8 is 10 over 4 is 5 over 2. 2.5? And now I can move that to here. Mu is going to be 9.8 sine 16 minus 2.5 all over 9.8 cos 16. Come back. 9.8 sine 16 minus 2.5 divided by bracket 9.8 cos 16. 16. Close off the cos, close off the bottom. Do you get 0.0213? Sorry, 0.0214? Now that's really small, and I got nervous. Wait a minute. We're on snow and ice. Should be small. I'd be more nervous if it was like a 0.7 or a 0.8. That's lousy skiing. Not going to work very well. So yeah, I'll go 0.0214. Units. Are none. Okay. If you got that, 4 out of 4. Otherwise, I would probably do something like this. I would give you a half mark if I saw that, a half mark for finding A. I would give you a half mark, a half mark, a half mark, a half mark for the numbers, and a half mark for the answers. Something like that. 1, 2, 3, 4, 5, 6, 7, 8. Half marks is 4. This question could be really yucky, except that right there, the fact that friction prevents it from moving, just made the question significantly better. It wants a free body diagram showing the forces acting on the bale of hay. I'm going to label my actual diagram. So here's what I need to see for the free body diagram. Half mark if you have an mg. Half mark if you have a normal force less than mg. Has to be less. If it's not, you lose that half mark. Half mark for having the applied at an angle. You don't have to label it, but there should be a force going up at an angle. Okay? Yeah.
What if we split the applied up?
Did you also put the applied on there? Okay, then if you did the components, that's okay, and I'll show you that in a second. And here's the other one as well. Is this accelerating? Is this moving?
No.
So I'm going to argue that friction needs to be exactly the same length as Fx, as the x component. Because if it wasn't exactly the same length, you'd have unbalanced horizontal forces, and this would have to be moving. So a half mark if you drew friction the same length as Fx. So the blue lines are your free body diagram, half mark for each one. Or Spencer, if you skip the diagonal, then you would also have an Fx and an Fy, FYI. Oh, sorry, friction, not Fx. Thank you. Has to be the same size as Fx. Now that's a very subtle idea, but Ange, it made the question way easier because B said calculate the force of friction. My first thought was to go, well, friction is mu times the normal force. Hey, what's mu? Oh. Hey, what? Oh. So I said, that's not going to work. But then I looked at my free body diagram and I went, friction has to be the same size as Fx. And I think that means that friction is equal to the applied force. Is it cos theta when you do the trig? Lena nodded. So friction is going to be, how big was the applied? 140 cos 28. 140 cos 28. And I get 123.612. I'm going to store this on my calculator. I'll call it 124. I'll take 123.6. I'll call it 124 newtons. That would get you 2 out of 2. So I would give you 1 mark for that. If you had that revelation, realizing that friction was equal to Fx, I would give you a half mark if somewhere I saw the cosine, and then a half mark for the answer. Calculate the normal force exerted by the ground. Unfortunately, I can't say, oh, look, another force the same size as a normal force. It's not mg. What I can say, Jordan, is I know several other forces. In fact, what I would say is, am I sinking to the ground? No. Am I flying into the air? No. Everything up. Has to equal everything down, which means the normal force is going to be mg minus Fy. It means the normal force is going to be mg minus 140 sine theta. The applied force sine theta, which is going to end up being, what was m? Did they tell me? 55 times 9.8 minus 140 sine. What was theta? 28. You get 473.273. I'll write 473. That gets you 2 marks. I would give you 1 mark if I saw that. I would give you a half mark if somewhere I saw sine theta, and a half mark for the answer. Now, if you just said normal force is equal to mg, nothing. Sorry. However, for the final one, for 1 mark, I know that friction is mu times the normal force. That means that mu equals friction divided by the normal force, where friction is going to be 124 and normal force is going to be 473. Well, actually, it's going to be 123.612663 divided by my answer button. You get a friction coefficient of 0.261. I'd probably take anything between 0.25 and 0.27 because there's probably been some rounding up. Am I right? Is it 0.261? For you to get 1 mark, I would probably give you a half mark if I saw that you would realize that mu is equal to friction divided by normal force. Now, if you got any of these ones wrong, but you did go your answer from B divided by your answer from C, I would give you the full mark here because you did it correctly just with the wrong data points. But your method was fine. Can you give yourself a lovely, lovely, lovely score out of 29? Wow.